Section 2.6 Related Rates. Related rates is an amazing application of chain rule and implicit differentiation combined. You are about to learn how to find the rates of change of two or more related variables that are changing with respect to time in our real-life problems. How exciting! Let's start. First, let's practice how to write these quantities as we learned. Write an expression for each. The rate of change of volume with respect to time. So whenever we see the rate of change, this is the derivative. Derivative is the rate of change. Slope is the rate of change of a function. So when they say rate of change of a volume, your function is a volume now, and we're trying to find the rate of change of a volume, which is derivative of volume with respect to time. And you guys know with respect to is what variable we are taking derivative of. So that will be dt in the denominator. So then how do you write it? It is rate of change of a volume with respect to t, or v as a volume function, rate of change of a volume with respect to t. They're the same. Either way is fine. The rate of change of length of a rectangle. So this time what's changing? Length is changing. So you can look at length of a rectangle as a function. And that will be what again? That is derivative of length with respect to its width. Now by width. So then how do we write it? That will be dl dw, right? Or derivative of length with respect to width. Get it? All right, let's do a little more. This is very similar to what we are going to do in 2.6. Suppose a point is moving along the graph of y equal cube root of x with dx dt equal 5. Find dy dt when x equal 8. So they gave you rate of change of x variable, and they want you to find the rate of change of a function at the moment when x is at 0.8. So the way we do is you first verify what's given. And what's given is this. And then you identify what is that you have to find. So you have to find this guy. You want to know what the dy dt is. And another known value is x equal 8. That's the point when you want to find out. Because the rate of change of y changes at any point x. So they're asking what is the rate of change of a function at the moment when x was equal to 8. That's the question. So what do we do? Do you notice that these are both dx dt and dy dt? So x is the function of t, y is a function of t as well right now. So we need to do implicit differentiation for both x and y with respect to time. So let's go ahead and do that. Let's take the derivative of both sides of y equal cube root of x. I'm going to first rewrite y equal cube root of x as y equal x to the 1/3 power. Okay, we're taking implicit differentiation on both sides with respect to t. So derivative of y is 1 times chain rule dy dt equal. This time, we're not taking derivative with respect to x. It is with respect to t. So even x to the 1/3 power, you're doing implicit differentiation. So this will be 1/3 x to the lose 1 power, which is negative 2/3 now. But you still gotta multiply by dx dt, by chain rule. Alright, so I found what my dy dt should be. My dy dt is, it is 1 over 3 cube root of x squared times dx dt. And they want you to find dy dt when x equal 8. And they also give you the quantity dx dt, rate of change of x. So now you can plug those values that you know to find the dy dt when x equal 8. So let's plug it in. Dy dt at x equal 8 is going to be 1 over 3 times cube root of, my x is 8, so you plug that in there, 8 square times dx dt, they said it is 5, which is equal to 8 squared is 64 and cube root of 64 is 4. So I have 1 over 3 times 4 times 5, which is equal to 5 over 12. So you found your dy dt here. So here is how to solve related rate problems. First, write down all quantities that are known and the quantity to be found. So that's what you identify. Find out what is that the problem gave it to you, what is that they're asking you to find. Step 2, come up with an equation that is related to step 1. Earlier, they gave us an equation, but typically in a word problem, they don't tell you what's the equation that are related to all these variables they talked about in step 1. So you need to come up with equations that are related with the variables that are known and to be found. Step 3, you will differentiate both sides of the equation implicitly with respect to time t. Step 4, substitute all known values into the resulting equation from step 3 to find the quantity to be found. Okay, let's see now if we can apply how to solve related rate problems to a real problem. Example, the radius of a circle is decreasing by 2 millimeters per second. Find the rate of change of the area of the circle at the instant the radius is 9 millimeters. Do you understand? This circle is decreasing in size and it is decreasing by radius 2 millimeters per second. And because radius is decreasing, then the area of a circle will be also changing with respect to time t, right? So they're asking you, what is the rate of change of area of a circle at the moment when radius is 9 millimeters, okay? So let's see if we can relate this to a problem. So what's step 1? I will have a first couple problem with this direction on it, and then again we will do the rest without the direction to see if we can do it without directions. Okay, so write down all quantities that are known and the quantity to be found. So first, they said the radius of a circle is decreasing, right? So radius of a circle is decreasing, so that's the rate that they gave you, 2 millimeters per second. So now we need to write that mathematically, since it's the rate of radius with respect to time t, that will be the dr dt, and it's decreasing. Decreasing and increasing obviously gotta be different, right? Because it's decreasing, we're gonna use the negative 2 millimeters per second. So you have to be careful, right? Because it doesn't say negative 2 millimeters per second. By looking at the word decreasing, it is you who should know to put the negative there. Now, find the rate of change of area. So that's what you have to find since they told you to find. Find what? Rate of change of area of a circle. So I have to find rate of change of area respect to t when the instant radius is 9 millimeters. So what they also gave you is the moment radius is equal to 9 millimeters. Well, they didn't give you an equation to work with, right? You're the one who need to come up with an equation that is related to all these variables they talked about in step 1. So I have a radius. They want you to find the rate of change of area. Then I need an equation of a circle that involves a radius and the area. So yes, you would need to use area of a circle formula. So typically, it's not very hard equation that you have to come up with, and you don't have to create an equation. It will be typically equation that you have learned previously. So now equation that we need to work with will be area of a circle equal pi r square. Area is changing and radius is changing. So those are your variables. Pi is just a number. So that's not your variable. Now we need to take the derivative of both sides implicitly with respect to t because I have to find dA dt. This equation doesn't give me what dA dt is. So we're going to take the derivative of both sides now. Derivative of a respect to t is 1 times dA dt. And derivative of a pi r square respect to t will be, pi is just a number, so you just leave it there. And then r square, when you take the derivative, it is a 2r, but now chain rule, dr dt. Okay, so now you will be able to find dA dt because your dA dt is already isolated on the left-hand side. And we do know the r at the moment when we're trying to find the dA dt, and we are given dr dt. So we will be able to find dA dt now. So dA dt at, what's the instant? Radius equal 9 millimeter is equal to pi times 2 times the radius. Radius is at the moment 9 millimeter, and dr dt is negative 2 millimeter per second, which is equal to 2 times negative 2 is negative 4. Negative 4 times 9 is negative 36 pi. And what is the unit here? It's a rate of change of area, right? If you notice, you do get 9 millimeter here, and the negative 2 was a millimeter per second. So when you multiply all this, you get millimeter square per second is the rate you get. So you just found your dA dt at r equal 9, and it is negative 36 pi millimeter square per second. Next problem. A spherical balloon is being inflated with helium at a rate of 12 inch cube per minute. What is the rate of change of its radius when the radius is 8 inches? Alright, so let's do the step 1. Write down all quantities that are known and the quantity to be found. So they are saying the balloon is being inflated at a rate of 12 inch cube per minute. So what is changing here? The volume is changing. That's right. So the rate of change of volume respect to t is right now what's given, and it is positive or negative. It is being inflated, so it's getting bigger. So it is positive. It's increasing. 12 inch cube per minute. And they said, what is the rate of change of its radius? They're asking to find what now? They said find rate of change, which is the derivative of radius with respect to t when the radius is 8 inches. At the moment when radius is equal to 8 inches. That's the problem. So now I need to come up with an equation that is related to all these variables they are talking about. We're talking about volume here, and we are talking about sphere, and we're talking about the radius. So I need equation that has to do with the volume of a sphere. So the volume of a sphere formula, do you guys recall? The volume of a sphere is equal to 4/3 pi r cube. is the volume of a sphere formula. If you forgot, memorize it now. You need it, right? Okay, so volume of a sphere equal 4/3 pi r cubed. Now, what do? We differentiate both sides of the equation implicitly with respect to time t. So let's take the derivative. Then I take the derivative of v with respect to t. That will be 1 times chain rule dv dt, and 1 times dv dt is just dv dt. 4/3 is just a number, pi is just a number. Take the derivative of r cubed with respect to t. That will be 3r squared times chain rule dr dt. All right, this time my dr dt is on my right hand side, and that's what I need to find, right? Dr dt. There's 2 ways to do it. You can just plug all the numbers that you know now and then solve for dr dt, or you can solve the equation you have right now for dr dt and then plug the value in. Either way is fine. So I will just solve for dr dt. So to do that, let's get rid of a 4/3 first. To get rid of 4/3, you can multiply both by reciprocal, and reciprocal of 4/3 is 3/4. So then you can divide both sides by 3 pi r squared. Then you will have dr dt will be equal to, you have a 3/4, and then when you divide both sides by 3 pi r squared, I get 1 over 3 pi r squared in the denominator, and you have dv dt. Now you can plug it in, the value. So my dr dt at r equal 8 inches is equal to 3/4 times 1 over 3 pi, r is 8 inches, square dv dt is 12 inch cube per minute. So you can plug in there. dv dt is 12 inch cube per minute. Look at the units. You get inches square here, and inches square with the inch cube get canceled. You only get inch left. So you will have inch per minute because it is the rate of change of a radius with respect to time t. So this will be equal to, let's see, anything cancel. I get 3 goes there once, 3 goes there 4 times, and this 4 and this 4 get canceled. On the numerator, I got 3 times 1 times 1, so I have a 3. In the bottom, I had a pi. 8 squared is 64, so I have a 64 pi there, and I get inch per minute. So my answer, dr dt at r equal 8 inches is 3 over 64 pi inch per minute. Now let's try a problem without directions to see if we can do it. 2 cars leave the same point at the same time. One travels east at 50 miles per hour, while the other travels north at 80 miles per hour. How fast are the cars moving away from each other after 2 hours? When you do this type of a problem, it is so much helpful if you draw a diagram. Sometimes visualizing also give you equation that you couldn't think of otherwise. Okay, so let's draw the picture. 2 cars leave the same point at the same time. So I'm gonna draw this point to be the same point that they left at the same time. One travel east and one travel north. And one traveling east, we need to come up with the variables. Let's call it x. And going north, let's call it a y, since one is x direction and one is y direction. And what is given to me? They said one travels east at 50 miles per hour. That's a rate, right? That's a speed, which is a rate. It is how fast x is moving with respect to time t. So that will be dx dt, which is equal to 50 miles per hour. And they also gave me the speed for how fast y is moving. So that will be dy dt, and dy dt is 80 mile per hour, and they gave it to us. And they're asking how fast are cars moving away from each other after 2 hours. So if cars are here and here, then this is how far they are away each other. And if a car's over there and here now, this will be how far they are away each other. At the time when time hits 2 hours, how fast are these cars moving away? So you are trying to find out how fast this is moving away from each other. So let's call that a z. So the quantity you want to find is since how fast this is moving. They're asking you to find dz dt. So given dx dt, dy dt, I want to find dz dt. So looking at this diagram, do you happen to think of any equation related to this x and y and z? Yes, we have a right triangle. Car going east and car going north make 90-degree angle, and they are making this right triangle. So we have a Pythagorean theorem. So equation that you could come up with will be hypotenuse square equal leg square plus the leg square. That's the Pythagorean theorem, right? So now we need to take the derivative of both sides with respect to t. So take the derivative of 2z, take the derivative of z squared, you get 2z dz dt equal 2x dx dt plus 2y dy dt. So to solve for dz dt, since that's what you want to find out, all I have to do is now divide both sides by 2z. And then since every factor has a factor 2, 2's can be cancelled. My dz dt is equal to x times dx dt plus y times dy dt over z. So I understand I'm given dx dt and dy dt, but where is my x and where is my y and where is my z? They didn't give it to me. How am I supposed to find that and plug it in there? Well, there is a hint that we have not used that they gave us in the problem. They were asking how fast are cars moving away from each other when is this? When t is equal to 2 hours, right? And distance is equal to rate times time. So when you have the rate and when you have the time, you can find out what the x has to be. You can find out what the y has to be. And if you know the x and the y value, then by Pythagorean theorem, you can find the z as well. So x is the distance traveled east. You're going at 50 miles per hour for 2 hours. You would have traveled 100 miles. Similarly, you can find the y by it's a rate times time, and rate is 80 miles per hour for 2 hours, so that will be 160 miles. Now using x equal 100 and y equal 160, you can find the z. Now plug those values right here. So if you do that, then I'm gonna get z squared equal 100 square plus 160 square. I'm not even gonna solve it because at the end I'm gonna use calculator anyway. So your z is a distance, so it's a positive number. Z is a positive square root of 100 square plus 160 square. We're gonna plug those numbers in now to find the dz dt at t equal 2. So finally, dz dt at t equal 2 is equal to, my x was, I found 100. dx dt is 50 mile per hour plus y is, we found a 160 times dy dt is 80 over square root of, it's a z. Z, you found it right here. Z is square root of 100 square plus 160 square. And when you use calculator, you get about 94 miles per hour is what you get for dz/dt. So you found your answer. Next example. A light is positioned at the top of a light pole that is 20 feet tall. A 6 feet tall woman runs away from the light pole at a rate of 8 feet per second. A. Make a drawing. B. At what rate is the tip of her shadow moving away from the light pole? C. At what rate is the length of her shadow changing? So to figure these problems out, it will be really helpful to do the drawing. So let's make a drawing. I have a light pole, 20 feet tall, standing on the ground, and there is a woman walking away from the light pole, and she's 6 feet tall. And because she's walking away from the light pole, there will be shadow in front of her. So with the light and her height and the tip of shadow will make a right triangle, and her shadow will be right here, and this will be her tip of shadow. So then what information is known? It says woman runs away from the light pole at a rate of 8 feet per second. And woman is right here. So let's say where the woman is standing as she walks away, it is changing because she's keep running away from it. But wherever she is, let's call this distance x. Then it's giving you the rate at which she is running away is 8 feet per second. So that will be what's given? Dx dt is given. She's running away at a rate of 8 feet per second. Okay, and now at what rate is the tip of her shadow moving away from the light pole? So we said this is her tip of shadow, and that depends on x, right? Depends on where x is, her tip of shadow will be changing as well. So since it's changing with her walking away from the pole, because we need to find at what rate tip of her shadow moving away from the light pole. Let's call this whole length y. So since it's asking at what rate tip of her shadow moving away from the light pole, what they are asking you to find is dy dt then. That's the quantity that needs to be found. Then how can I come up with an equation? Pythagorean theorem doesn't work here, right? Because I have a bunch of variables x and y in the one side of a triangle, and I only know the base, and I don't have a hypotenuse either. Instead, you can look at these two triangles. There is one triangle made by her tip of shadow and the woman and the ground. This is one right triangle because the person, when it's standing, it is perpendicular to the ground. And there is another triangle that is made by the light pole and the ground with the tip of her shadow. That is a larger triangle. And it's also a right triangle, since a light pole and a ground will make a 90-degree angle there. And this both the triangle I just talked about, they are both having same angle where her tip of shadow is. So they both share this angle. So by AA theorem that we learned from geometry, AA theorem is if two angles of a triangle is equal to two angles of another triangle, then two triangles are similar. And what about similar? If two triangles are similar, then their corresponding sides are proportional. So by AA theorem, two triangles are similar and their corresponding sides are proportional. So therefore, we can come up with a proportion. So one leg of a smaller triangle is to corresponding leg of a larger triangle. That will be 6 to 20. That has to be equal to another leg. What is this length here? Whole leg of a bigger triangle is a y. And from light pole to woman, the length is an x. So the remaining should be then y minus x. right? So now 6 to 20, that has to be equal to that leg of a smaller triangle, y minus x to y. So then now I have a proportion, so you can cross multiply and set them equal to come up with an equation to do with x and y. So now you multiply cross 6 times y, that has to be equal to 20 times y minus x. So when you distribute, you have a 6y equal 20y minus 20x. Now I'm gonna move x to the left, y to the right. So then I have a 20x equal 14y. And you divide both sides by 14. I get y equal 10 over 7x. Now what do? Well, I still need to find dy dt. And to find the dy dt, I need to then take the derivative of both sides with respect to t of this y equal 10 over 7x. So let's take the derivative of both sides now. Then dy dt, because derivative of y is 1 times dy dt is dy dt equal to derivative of 10 over 7x is 10 over 7 dx dt. Do we know dx dt? Yes, we do. The problem gave it to us right here. Remember? So you're gonna have to plug it in there to find the dy dt. So then that will be 10 over 7 times dx dt is 8 feet per second. So when you multiply, you're gonna get 80 over 7 feet per second. That is the rate at which her tip of shadow moving. So we just found the dy dt, and it is 80 over 7 feet per second. Now, at what rate is the length of her shadow changing? And what is the length of her shadow? Yes, remember we said her shadow is right here. This is her shadow. And that length is y minus x. So we want to find rate of change of y minus x with respect to t. So now dy minus x with respect to t. Rate of change of y minus x with respect to t, which is equal to, what is it? What's the derivative of y respect to t? That will be 1 times dy dt minus, what's the derivative of x with respect to t? That will be 1 times dx dt. And we just found the dy dt right here, and dx dt was given. So you can use those information to find what rate the length of her shadow changing. So dy dt is 80 over 7 feet per second. Subtract dx dt is 8 feet per second. So when you subtract, let's get a common denominator 7. That will be 80 minus 7 times 8 is 56 feet per second, which is equal to 24 over 7 feet per second. So you also found the rate at which the length of her shadow changing. It is 27 over feet per second. Let's do a couple of challenging problems. Water is flowing into a conical tank at a rate of 15 cubic feet per minute. The diameter of the tank is 20 feet and its height is 12 feet. Find the rate of change of the depth of water at the moment the water level is 8 feet deep. Do you get the problem? Right now, water is flowing into this tank, and it is coming in at a rate of 15 cubic feet per minute. So what did they just give you here? They gave you the dV dt, because the volume is changing, right? And this is the volume of water, since it's the water flowing into the tank at a rate of 15 cubic feet per minute. So you can see how when water is flowing into this tank, it will be also making a cone shape as well, right? When water coming in, it will be also filled from the bottom. So it will be like that. So now what's known is they gave me dV dt, the rate of change of a volume of water. It is positive because water is coming in 15 cubic feet per minute. The diameter of a tank is 20 feet. So then radius will be 10 feet. And the height of this original tank is 12 feet. And it says find the rate of change of depth of water. And that's what you have to find. You have to find the rate of change of depth of water. So let's say this depth of water is the height h of the water. And this will be radius of water. So then I have to find, since it says rate of change of depth of water will be dh dt. At the moment, the water level is 8 feet deep. Water level, that's a h, when h equal 8 feet. Now, I need to come up with an equation that has to do with this volume of water and the radius of water and the height of water so that we can use a given quantity dV dt and find the dH dt when h is equal 8 feet. So what formula do we need here? That will be volume of a cone formula since our water is cone shape. So what will be the equation of a volume of a cone? Volume of a cone is 1/3 pi r square h. Yeah? Now what is the problem here? I know volume is changing as a water coming in. I know radius is changing. I know depth of water, which is the height of water, is changing. But when I take the derivative of this with respect to t, I have a 3 variable here, and I don't have any information about r. I don't have a dr dt, I don't have a r. I only have information about h or dv dt. So if I kept the r here, I will be stuck here. So then what do we do here? We have to find a relationship or an equation that is always true between r and h so that we can get rid of r here without changing the original problem. So again, you can see this original shape of a triangle, which is right here. That's a right triangle, right? Because this is a 90 degree, and when water is coming in with the water level with this tank, it also makes the right triangle, and they are both sharing this angle. So again, by AA theorem, these two triangles are similar. So then we have relationship. Corresponding sides are proportional. So the radius of larger cone, which is the leg of a right triangle, 10 feet, to radius of smaller cone has to be proportional to the leg of larger triangle, which is the height of a larger cone, which is the 12 feet, to height of water, which is the h. So then by cross multiply and set them equal, 12r has to be equal to 10h. Divide both sides by 12. So r can be replaced by 5/6h. And you are going to replace it right there, because this is always the relationship with r and h because they're similar triangle. So then v is equal to 1/3 pi, r is 5/6h squared times h, which is equal to 1/3 pi 25/36h squared times h. So finally, your v is equal to 25 pi over 108 h to the third power. Now, this equation has only v and h as a variable. So when we take the derivative of both sides, we have no problem now. So now let's take the derivative of both sides of v equal 25 pi over 108 h cubed with respect to t. So when you do that, I get derivative of v is 1 dv dt, which is just dv dt, which is equal to 25 pi over 108 h cubed. When you take the derivative of that with respect to t, you get 25 pi over 108 times derivative of h cubed is 3h squared dh dt. And then 3 and 108 gets to be reduced. So 3 goes there once, 3 goes there, 36. dv dt is then 25 pi over 36 h squared dh dt. And you want to find the dh dt. So let's multiply both sides by reciprocal of what's in front of dh dt. So when you do that, reciprocal is what? 36 over 25 pi h squared. 36, 25 pi h squared. So that this is gone. So then your dh dt at when h equal 8 feet is equal to 36 over 25 pi, and our h is in the bottom, so you need to put the 8 feet in the bottom, square, times dv dt, and dv dt is right here, which is 15 feet cubed per minute. So then you can reduce 5 goes there, 5 goes there 3 times, 5 goes there 5 times. 8 feet square, that's a 64 square feet. And 4 goes there 9 times, 4 goes there 16 times. And then feet square cancel. I get a feet per minute left there. So your dh dt finally is 9 times 3, which is 27. And 5 pi times 16, which is equal to 80 pi. And your unit, as you see what's left, it will be feet per minute. So you just found your dh dt, and your dh dt at height 8 feet is 27 over 80 pi feet per minute. Last example. A balloon rises at a rate of 8 feet per second from a point on the ground. An observer is located on the ground 40 feet from the launching point. Find the rate of change of the angle of elevation from the observer to the balloon when the height of the balloon is 25 feet. Are we getting this? Let's draw the picture again. It will help us to understand. So there's a balloon and it is rising from the ground. And here's an observer located 40 feet away from the launching point. So as the balloon rises, the angle of elevation will change. Is that right? And that's what they're asking you to find. So balloon is rising. We can call that h for the height of a balloon. How is it changing? It's changing at 8 feet per second, and it is increasing, right? Height is increasing. So what they gave it to me is dh dt. dh dt is 8 feet per second, and they want me to find rate of change of an angle. So let's just make one triangle just so that it's easier for us to understand. And this will be angle of elevation, and it is asking you to find d theta dt at the moment when the height of a balloon is equal to 25 feet. And again, this is a right triangle because the height and the ground will make 90-degree angle. So now h is changing and theta is changing. So what kind of equation can I have here that relates h and theta? And perhaps you can use 40 as well, although 40 is a constant. Yes, tangent theta, right? Soka toa. So toa, tangent theta is equal to opposite, which is h, over adjacent. Adjacent is 40. So tangent theta is 1 over 40h. So now you can take derivative of both sides of this equation. So take derivative both sides with respect to t. Then derivative of tangent is secant square theta. Now you need to take the derivative of theta, which is 1, and chain rule d theta dt, which is equal to derivative of 1 over 40h with respect to t is 1 over 40 dh dt. And because I have to find d theta dt, you can divide both sides by secant square theta. So your d theta dt is equal to 1 over 40 times dh dt times 1 over secant square theta. But what is 1 over secant square theta? That is cosine square theta. So I need 1 over 40 times d theta dt times cosine square theta. How do you find cosine theta square? Find the cosine theta. How? Well, it's when h is 25 feet. So when h is 25 feet and your adjacent is 40 feet, so then hypotenuse is square root of 40 square plus 25 square, which is equal to square root of 2,225. So then what's the cosine of theta here? Cosine is ka, adjacent over hypotenuse. So that is 40 over square root of 2,225. So now we can finally find our d theta dt. So d theta dt at h equal 25 feet is equal to 1 over 40 times dh dt is given, and it is 8. And cosine theta we found, it is 40 over square root of 2,225 square, which is equal to 1 over 40 times 8. When you square the 40, you get 40 times 40. When you square the radical, you get the number without radical. So then I can cancel the 40 and that 40. And 5 goes there 8 times. 5 goes there 445. So on the numerator, I have 8 times 8, which is 64. And denominator is 445. Our d theta dt unit is radians per second. And if you run the calculator, it is about 0.14 radian, 0.14 radian per second. So we finally found our d theta dt right here. All right, this is for 2.6. Please study hard, and I will see you now in chapter 3.